This is Euclid Book 2, proposition number 12, and I wanted to tell you that we're only 2 proofs away from finishing Euclid Book 2 completely. But keep in mind, there are 13 books to Euclid's Elements, so we're a long ways away from finishing Euclid Elements completely. First of all, Euclid wants you to draw an obtuse angle triangle. And that triangle is going to be BAC. And as you can see here, the angle BAC is obtuse. Okay? Then Euclid wants you to extend line CA out to D, and then he wants you to draw a line from point D to point D, which is perpendicular to line CD. For your first bit of homework, I want you to tell me what proof Euclid uses to draw a perpendicular line from point B to point D that makes it perpendicular to DC. You've been told this several times before, and now you need to tell me. Okay, now then, because we've drawn this perpendicular line, then we can establish that angle BDC is a right angle. But we can also establish one other thing. There are 2 right triangles that you are seeing right now. The first one is BDC, okay? And the second one is BDA. Okay, so let's get down to the nitty-gritties of the proof. The square on CD is equal to the following sum. The square of CA, the square of DA, and twice the rectangle contained by CAAD. So what does that all mean? Well, the area contained by square CD is equal to the sum of the area of square CA, the area of square DA, plus, if we were to draw out the rectangle CAAD, and multiply the area inside of it times 2, then we could add it to CA and DA and get CD. Now, we're going to add the area of BD right here to both sides of the equation. See, we added it here, and we're also going to add it here. Alright, now, the first thing we're going to do is we're going to replace CD right here with CB. Well, actually, we're going to replace CD and BD. We're going to replace this whole term right here with this. How do we do this? Because we can establish that the area inside of square CB is equal to the area of square CD plus DB. Now, how do we do all that? Well, that's by Euclid Book 1, proposition number 47. And you should have recognized this top equation up here because it is Euclid Book 2, proposition number 4. Okay, this equation up here is Book 2, proposition number 4. This equation here and this equation here are Book 1, proposition number 47. That's right, the area inside of square AB is equal to the area inside of square AD plus the area inside of square DB. So now we're going to replace AD and DB with AB, and CD and DB with CB. And here's how we're going to do this. The area contained by the square CB is equal to the sum of the following. And that would be the area contained by square AB plus the area contained by the square CA plus twice the area contained by the lines CA and AD. Alright. Now, as you can see here, my bottom equation has a slight mistake. Instead of an equal sign, we got to have a greater than sign. So, now that we fixed that, we can finally go on here. The area contained by the square BC is greater than the area contained by the square AB and the area contained by the square AC. So if you were to add this area and this area together, they would be less than this area by the amount of twice the area of CAAD. Okay? So, what's the second part of your homework assignment? What we have just talked about here is the equivalent of the law of cosines. And I challenge anyone to explain the law of cosines as it is referred to in Euclid Book 2, Proposition 12. And I may talk about that in a future lesson, so stay tuned.